So welcome to this is the Further Math Support Programme online revision session for Edexcel S3, and in this session we're going to be looking at how we combine random variables. So we need to be able to find the mean and the variance of a combination, and when we talk about combination we are really meaning a linear combination of random variables, and invariably we are using the normal distribution to do this because it's the simplest distribution to be able to combine. Now, one thing you need to be very aware of is the difference between a combination of random variables and also a function of a random variables. So for instance, to give you some idea of this, if I've got xi, so a selection of samples taken from a distribution x with a given mean and a given variance, you need to be very aware that there's very much a difference between x1 plus x2 plus x3, which means you're sampling 3 times from the normal distribution, and 3x1, which means you're taking a single sample and you're multiplying it by 3. And this is where a lot of students go really wrong on these. So we do need a full awareness that there's a difference between linear combinations of random variables and functions of random variables. Okay, so based on that, we need to, once we've worked out means and variances, we can also find distributions of the random variable combinations, and as a consequence we can therefore find probabilities based on that. So, June 2010, question 2. Philip and James are racing car drivers. Philip's lap times in seconds are normally distributed with a given mean and variance, mean of 90 and a variance of 9. James's lap times are given with a mean of 91 and a variance of 12. And the lap times of Philip and James are independent. That's really quite important for this to work. Before a race, they each take a qualifying lap. Find the probability that James's time for the qualifying lap is less than Philip's. So to do this, we need some ideas and some definitions. So to do this, it's very sensible to use sensible notation. Okay, so we've got Philip, and we're told that Philip is a normal distribution with a mean of 90 and a variance of 9. Okay, and I always like to write this as sigma squared. James, he's got a mean of 91 and a variance of 12, so I'm going to write that as root 12 squared. Okay, it might be that I need to use 9 and 12, but when we're working with probabilities, sometimes that's a bit easier to deal with. And what we're asked to do is we're asked to find the probability that James's time is less than Philip's time. So if we just read as it comes, that's exactly what we're looking for. Now, we can't compare probabilities, so what we have to do is we have to actually change this so we're looking at a numerical value. So we're going to look at j minus p has to be less than 0. Now, there are other ways of doing it, but this follows naturally from the sort of discussion in the question. So I need the distribution of j minus p. Okay, so what we need to be aware of is how the rules work. So there is a formula that says if you've got the expectation of ax plus by, then this becomes aex plus bey. Okay, that's quite a standard sort of definition. Also, we're told that the variance of ax plus by, and that will be plus and minus here, so that's plus and minus here. The variance will in fact be a squared variance of x plus b squared variance of y. And again, this is plus and minus, but notice it's always a plus here. So these are things that you're given. So really, it's the second rule that I'm going to be using. Now again, as you'll see in a later question, how we define these is very important. But for this one, we can see that we're going to be using this. So in other words, to work out the distribution of j minus p, that's going to be the difference in the means. So this is going to be modelled, it's going to be modelled as a normal distribution of j minus p is going to give me a mean of 1, and the variance is going to be 3. Okay, it's going to be 12 minus 9. Okay, so 12 minus 9, which is going to give me 3. And again, I'm going to write that as root 3 squared. So the question now can be answered. So it's the probability that j minus p is less than 0 based on my distribution. Now, of course, that can be looked up. Sorry, it's 12 plus, so that's root 21 squared. Let me just clear that up for a second. Okay, so now solving this, we are going to normalize it in the same way that we would. So we need to recognize that z is equal to x minus mu on sigma. So that's going to be x, which is 0, minus mu over sigma, which is root 21, and that's the whole reason why I prefer to write things as sigma squared. That's going to give me a z value of minus 0.2182. Okay, so in other words, we're looking for the probability that z is less than minus 0.2182. So to do this, we need to use our z tables. So just as a reminder, z was minus 0.2182, so we look up the positive z. So again, we can only do this to two significant figures, so that's going to give me a probability of 0.5871. So the probability here, so the probability that z is less than minus 0.2182 with your finest S1 is going to be 0.4129. Okay, so where are marks awarded here? That's quite important for this question. We've got 4 marks. So you're going to get effectively here, let me change colour so you can see, you are effectively going to be getting 2 marks here. And that's for working out the distribution correctly. And you get a dependent method mark for working out the z value correctly. Now, this is very important that it's dependent. If you don't get the method, i.e. combining the distributions together correct, we just don't mark the rest of the question. So it's very, very important you're aware of that. You then only get 1 mark for actually getting the answer here. Okay, so question moves on, and what it's asking us for this time is find the probability that, let's just read it again. So the race is made up of 60 laps. Assuming that they both start from the same starting line and lap times are independent, find the probability that Philip beats James in the race by more than 2 minutes. So we need to understand that Philip has got 60 laps, James has got 60 laps, and we need to combine these. So there are 60 samples for James and there are 60 for Philip. So let's define x as being all of the lap times of Philip. Now they're each different. Okay, so we can't just combine it in the normal way. We have it in the way that we sort of done on S1. We need to realize that they are all different. Let's do this as James first actually. So let's take James and let's take Philip and let's take all of the lap times away. And what we're looking for, plus P60, is that Philip beats James by more than 2 minutes. Okay, so we need to understand what's going on with x. So we'll look at that in a minute. But what we can do is we can realize what we're doing here. So we're combining 60 means together. So this is going to be 60 expectations of ji minus 60 expectations of pi. Okay, and to work this out, each expectation of t is the same, of j, sorry, so that's going to be James. Okay, so that's 91. And for Philip, that's going to be 60 lots of 90. So we can see we're going to get a mean of 60. Okay, and if we do the same thing for variances, now this is where we've got to be really, really careful. With variances, it's not 60 lots of J1, it's J1 plus J2 plus J3, etc. So the variance of x is only going to be 60 lots of the variance of each Ji, plus, now that's really important, 60 lots of the variance of Pi. Okay, so if we work all of that out, that's going to be 60 lots of 9 plus 60 lots of 12, which gives me 1260. Okay, so what we can state is x follows a normal distribution with a mean of 60 and a variance of 1260, so root 1260 squared. Okay, so far we've got 3 marks. Okay, we get a method mark for defining and setting up x correctly. You're then going to get an independent b mark for working out the expectation correctly, and you're going to get an accuracy mark for working out the variance correctly. Okay, so now we've got to realize what's going on. So this is the time difference between James and Philip. So for Philip, to win, what we need to make sure is that he's going to have a time that's greater than 120. Okay, so what we're looking for here is the probability that x is greater than 120. And just to remind you, this distribution is normally distributed 60 root 1260 squared. Okay, so again, this is just now a standardizing question. So z is equal to x minus mu over sigma. If we work that out, that's going to give me a value of 1.69030. It does continue, but again, I'm only going to be looking at 2 decimal places for this. So this question turns into the probability that z is greater than 1.69. Now I don't like that, so I'm going to turn it round, as we should do, so it's cumulative. And then I'm just looking at 1.69 in the table. So it's 1 minus 0.9545, which is going to give me a value of 0.0455. Okay, so the final 2 marks, you get 1 mark for correctly standardizing and doing 1 minus, that's quite important, and your final accuracy mark for getting the correct value at the end. Okay, so moving briefly on to June 2011, question 6. Similar sort of idea. Lifetime of batteries for manufacturer A are normally distributed with a mean of 20 and a standard deviation of 5. So be very careful that you're reading it correctly. We're told the mean and we're told that the standard deviation, so that's 5 squared. A lot of students do mix up standard deviation and variance when they're writing it down, so be very, very careful. So we're asked to work out the mean and standard deviation of the total lifetime of 6 batteries. So what you need to realize is that the total, let's call this A actually, and there are 6 of them, so let's call it AI. So the total lifespan is going to be A1 plus A2 plus A3 plus A6. So just pad this one out a bit more. The expectation of L will be the expectation of all of these, which is the same as each expectation added individually. E8 to the 6, and each one of those is the same, so we've got 6 lots of 20. So my mean is 120. Now to work out variance, let's look at the variance of L. Again, just to remind you, this is the same as the variance of each, plus a to the 6, and each one of these is linear and independent, so it becomes the variance of A1 plus the variance of A2 plus all the way up to the variance of A6. Okay, which is 6 lots of the variance. So that's why this kind of works the way it does. So 6 lots of the variance is going to give me that. Okay, which is 2550. So therefore the standard deviation of L is going to be the square root of 150. Okay, which is going to give me 12.2 or thereabouts. Okay, so that goes into a bit more detail about why and how the variance works. So you get 2 marks, effectively 1 mark for each. So Judy uses a camera that takes 1 battery at a time. She takes a pack of 6 batteries from a manufacturer A to use in her camera on holiday. Find the probability that the batteries will last for more than 110 hours on her holiday. So really this is the probability that the total lifetime that I'm looking for exceeds 110. And we've already established what L is. So L was a normal distribution where we're dealing with a mean of 120 and we were dealing with a standard deviation of 150. Okay, so I'm just going to leave it as variance for now. If you wanted to write it more formally in terms of standard deviations, which again is sometimes useful, we can do that. So again, standardizing is going to be the way forward. So Z is equal to X minus mu over sigma, which is going to give me a Z value of minus 0.8164. So in other words, it's the same as finding the probability of Z being greater than minus 0.8164, and this is really horrible on lots of counts, so we need to swap it round and deal with negativity, and if we do that, by symmetry you can argue that it just swaps over. So that's what we're tasked to do, work out the probability that Z is less than 8164. So 8164 we can't work out, so you do go to the nearest Z value. Okay, so the probability of z being less than 0.82. If you wish to interpolate, you can, but you don't get any marks for that. Or you could use a calculator, but ideally the tables are just more efficient. So this is going to give me a value of 0.7939. Okay, so where are your marks allocated here? Again, for standardizing questions here, you get 1 mark for standardizing and 1 mark for getting the correct answer. And then part C, find the probability that the total lifetime of a pack of 6 batteries from manufacturer A is more than 4 times the lifetime of a single battery from manufacturer B. So we're given here some information about manufacturer B. The lifetimes of batteries from manufacturer B are normally distributed with a mean of 35 and a standard deviation of 8. So again, we're asked to combine things. So we just need to work out what's going on. So it's always good to define something. So I'm going to let x equal the following. We want to show whether the probability that the total lifetime of a pack of 6 is more than 4 times the lifetime of a single battery. So I can define x in the following way. I'm going to define it as 4b minus a1 plus a2 plus a3 plus a6. Okay, because we're looking for the difference between the total lifetime of a pack of 6 batteries and 4 times the lifetime of a single battery from manufacturer B. So this is an interesting question because we've got both a combination and also a function of distribution. So we just need an awareness of that. So same idea, we can then apply this. So the expectation of x is going to be 4 lots of the expectation of B minus 120, because we worked that out earlier. Okay, so we can work this through. That's going to be 140 minus 120, which is going to give me a value of 20. Now the variance of x. So the variance of x, we're going back to our original idea, is going to be 16 the variance of b because it's a function, minus, and again we worked out the variance previously as being 150. So that's going to give me 16 lots of 8 squared minus 150, which gives me 1174. So in other words, x is a normal distribution of 20 root 1174 squared. And I want this to be 0 or less than 0. If I think about what x is the difference. It's 4b minus the total lifespan. And what I want is the lifetime of the 6 batteries to be bigger. So this has to be bigger than this bit. So if you've defined x in this way, it's not the only way. What I'm looking for is the probability that x is actually less than 0. Okay, so looking at that, we're looking at the probability that x is less than 0, from the distribution that's normal of 20 root 1174 squared. So again, we're going to standardize. So z is equal to x minus mu over sigma. We calculate that through, and that's going to give me, this is an equivalent probability to z being less than minus 0.583 and so on. So again, we go for the nearest z value, 0.7190. And again, you're not expected to interpolate at this level, so we can just use the given values. And so if we look at the positive one, this is going to be 1 minus the positive z value, 0.58. So that's going to give me 1 minus 0.7190, which is 0.2810. Of course, if you want to interpolate, you can, but that would be appropriate. So let's just look at your mark allocation for this. You're going to get, effectively, you get a lot of marks here. Let me just change colour so you can see a bit more clearly. You're going to get a B mark, for working out the expectation, and the variance is quite complicated. You're going to get 2 method marks and an accuracy. So your method marks are for splitting this up correctly. So 16 times 8 squared, and also recognizing that it's subtracting the 150. Adding the 150. Should have done that earlier. Does give you 1174 still. And then you get your final accuracy mark for getting the correct value, of course, in that particular context. Okay, and then you're going to get, as with all of these standardized questions, 1 mark for standardizing and 1 mark for accuracy. Okay, so that's pretty much it. So you need to be very, very aware and very, very careful of the difference between a function of A linear function, doesn't have to be linear, but a linear function of random variables, and also a combination of random variables. So make sure you're very, very aware of the differences between the two.